All right, why don't we just go ahead and get started here. Hello, everyone. My name is Vince Luciani. I am the Senior Sales Engineer here at SurgeX. Welcome to today's webinar where we will be taking a closer look at the upcoming new product, Squid. I'm sure most of you are sequestered in your home, and I think everyone on the panel is safe in their home today. If you don't know me, I'm in my second year here at SurgeX. I may have met some of you at Infocom or maybe at a past CEDIA. Maybe I came to do an office visit. A quick shout out to those of you who I just saw at ProSource in Vegas, probably the last industry show we will have for a little while here. For those who I had not yet met, my role at SurgeX is to travel with our sales team and help spread the technical side of the SurgeX story. As well as provide support to our dealers. That support comes in the form of helping you guys create a solid power foundation for your systems by assisting you in planning out your power strategy on a project you might have. If you ever have any questions on which SurgeX projects to spec in, please feel free to reach out to me directly or through your sales rep. Along those same lines, we have been conducting these webinars. Like the one that you're attending today. Today, we're going to be talking or taking a closer look at the upcoming SXDC series, a hybrid ACD power product that we affectionately call Squid. So we have a couple of guests today. First up, we have SurgeX Director of Marketing, Lauren Simon. Lauren, we're going to be talking today a little bit about the history of Squid and the design criteria that you came up with and some applications. Please say hello to everybody.
Hello, everyone. Thanks for joining us today.
And later on in the program, our project leader and lead design engineer, Dean Phillip, is going to be talking about the hardware specification and actually give us a sneak peek, a live view at the user interface. How you doing today, Dean?
Good, Vince. Thanks for having me.
Excellent, excellent. So before we get started, I wanted to make everyone aware of webinars we have completed thus far. We have webinars scheduled on the second to the last Thursday of the month at this same time, 11:30 a.m. Eastern and 8:30 a.m. Pacific. As you can see, we've covered some great topics. If you'd like to view these webinars, we have a link set up. You can see there on your screen at gotostage.com. If you don't write that down, of course, you can always contact your SurgeX sales representative and get that link sent to you. On this link, you're going to find other materials other than our webinars, some just kind of open discussions about power and how to create a solid power foundation in your system. So let's go ahead and get started. Lauren Simon, I'm sure you know her. She's Director of Marketing here at SurgeX and has been instrumental in the creation of Squid. So Lauren, the first question I have for you, what the heck is a squid?
So the squid is this thing that lives under the sea, but in our world here, the squid is an 8-port, it's 7 in 1 out, or I'm sorry, 1 in 7 out, hybrid AC/DC IP controlled power center. So we have 4 IEC outlets for individual control. We have 3 isolated DC outputs. There's 3 models of this, either all 12 volt, all 24 volt, or a hybrid of a 12 and 24 volt. It also has the IP control. For those of you who are familiar with the Axis Elite, you have your sequencing, your triggers, your scheduling, the ability to remotely manage and monitor all of your AC from the remotely, as well as a 12 and 24 bank. So you can reset those banks there as well. It also has the diagnostics coming from our Envision diagnostic tool. So the ability to look at line current, wattage, looking at your loads, looking at your timestamp of power disturbances. It also logs and monitors metrics such as voltage, neutral to ground voltage, current, things like that. So essentially what we've done here is we've taken the Axis Elite, the Envision, those softwares and firmwares, and put them into one chassis and made it in a little bit of a different form factor specifically for that huddle space, flex space environment where you may not have the ability to put something into the rack, but need to control and manage those rooms.
Excellent, excellent. Actually, that kind of leads into my next question. what were you seeing in the field that prompted you to come up with this very unique product?
Yeah, so it was, the original product was actually built like most products on a bar napkin or a cocktail napkin sitting in a bar in New York City some years ago. But we had been to a couple of dealers and a couple of end users throughout the day and throughout the week. And it really hit home for us one day when we were sitting in a conference space. One of our customers kind of looked behind the TV and we saw a Staples or a Home Depot surge strip. You guys are all familiar with them, literally Velcroed to the wall. And we were trying to get the TV on. He's like, oh, you got to check behind there. That wall wart's constantly falling out. You just got to plug it back in. It's a pain in the butt, but it's the only thing that works right now. So that got us thinking a little bit. Then we went to an end user who had, in one floor, they had 20 flex spaces set up. So some were four-person conference spaces, some were flexible spaces that you could, change and make modular for design thinking, whatever it might be. And about half of them were dark. And the IT director looked at us and he's like, yeah, those rooms are a pain. Half of them are down, but we don't have the staff to actually go out and physically look at them. Chances are they just need to be rebooted, but we have to go out physically to every room, and I just don't have the staff to do that right now. So that night we started thinking about, all these use cases where we've been hearing from customers of, the conference space is going away and it's going more towards these huddle and flex spaces. But DC has become a problem, so the wall warts tend to fall out because they're not in a rack environment. Connectivity becomes an issue because, let's face it, these things just sometimes need to be rebooted or reset. And the ability to actually see what's going on in those rooms, are they being utilized for what they're supposed to be for future planning? So we decided to take all of these and put it into this form factor that will work, whether it's a small rack design or behind the TVs or up under the table mount.
Yeah, let's talk a little bit more about the DC side of things. So the intention here is to get rid of wall warts, right? And I mean, we want our customers to basically cut the wall wart off and just wire directly the power cable that comes with the device, just wire it directly into us.
Yeah, so we can definitely do that. There's the ability to make custom lengths for you as well. So, if the power cord is 8 feet and you really only need 2 feet, it gives you that ability for some wire management. Additionally, there are some products on the market where you get the box, but you don't get the DC power supply. So you have to then go and spend more money to get that wall wart or get that power supply. So it just gives you the ability to customize it a little bit more, reduces the footprint of that device, and is a more secure connection. So you don't have to worry about things falling out or the connection going loose.
Isn't that incredible in this day and time, how much time is spent on plugging a wall wart in when that's the issue,
Yeah, it is, and we see it all the time. We see it with racks, we see it in these environments, we see it in really every environment that wall wart's just heavy, and when you start to hang it, eventually it's going to come loose. Or if somebody kicks it under the table, or somebody tries to move the table, we've seen this too of oh, we need to put the table on this side of the room right now, let's move the table, and it pulls the connection out. So there's a lot of things like that are just nuisance issues that just by doing something simple like this we can fix.
Excellent. So I have been showing the Squid around, a lot of excitement in the field, but the question I get a lot is, why were IEC chosen for the output, for the AC output?
That's a great question, Vince. And there's two main reasons. Initially, this device was going to have NEMA plug, so your traditional prong that you'd see in a 120 volt system. But as we started building some prototypes and getting it out into our customer base, the resounding feedback was NEMA was actually a better solution, because a lot of these things, such as TVs or some of the video conferencing systems or the audio systems, ran off of an IEC anyway. And with this, instead of having to have a transformer that was going to take up space behind there, they could actually run a custom cord length for whatever it was for their panel to the IEC, so that they didn't have feet or extra feet of wiring. The resounding feedback was actually surprising to us initially, that IECs were a much better bang for your buck for this type of application. The other side of it that we heard from all of our customers were, listen, we are looking to standardize globally. We want the same products in every one of our spaces. It doesn't matter if we're in Timbuktu or if we're in the US or if we're in Australia, we want the same product. So with this product, one of the unique features is that it is a global application. So it will work on 120, it'll work on 230, same box. So with the IECs, that makes it a global standard as opposed to just something that's built for North America.
Yeah, because it's IEC on the input and on the output. Yeah, so that makes it easy. And the other thing is when Dean gets on, he'll tell us designing with the IEC makes the package size smaller because the IEC connector takes up less footprint than an EMA plug. So it kind of worked out for everyone that way. So let's talk about the front end protection. What kind of protection technologies do we have in this unit?
So this runs off of our Defender series multi-stage surge suppression technology. It is, it still comes with the same 5-year connected warranty that all of our Defender series products have. The way that we do our multi-stage surge suppression is very different than than other manufacturers will traditionally do a single stage MOV. Because there are multiple stages, you guys have all seen us blow up the MOVs in trade shows over the years. The way that this technology works is that the MOV never actually sees heat. And so typically when an MOV will see that heat and it will oxidize from a surge event or a power anomaly, that's what causes those to degrade over time. Because of the multi-stage that we have in there, there is a gas discharge tube and a silicon avalanche diode that take the brunt of that hit, and the MOV strictly then becomes a pass-through device, so it doesn't heat, it doesn't oxidize, and it doesn't degrade over time. So it is still a very good surge protection technology. It is a little bit different than our surge elimination, but for the applications that we're protecting, this is a phenomenal technology for it.
Yeah, I mean, it allows the smaller size, because we all know we would love to put advanced series mode in everything, but advanced series mode takes up some space, so we had a space constraint in here. And the other thing about the hybrid design that we have with the MOVs and gas tubes is that they are not susceptible to overvoltages. That's a big problem that we kind of gloss over in the world of MOVs. If an MOV sees an overvoltage, it doesn't know the difference between an overvoltage due to a surge or an overvoltage due to the sine wave increasing in amplitude, and it's going to try to start to conduct under both cases. And if it starts to conduct during an overvoltage, it just simply blows up. It can't take more than one overvoltage event. So that's what's great about that gas tube. It prevents it from the MOV from turning on during overvoltage events. So excellent. Well, I think it's a good overview of the hardware. So let's talk a little bit about applications. You had mentioned before huddle spaces. So here's a picture of a huddle space.
Yeah, so initially this was built with the huddle space and flex space in mind. Again, those rooms that are transferring to traditionally you'd see a 20-person boardroom or an amphitheater type situation, which those rooms still exist, but with the prevalence of remote working, which we are all experiencing, I think more so than any of us ever wanted to right now. But prior to that, there was a push to have collaboration spaces in the office where productivity, and most businesses have seen the research and seen the studies that productivity and profitability increase when there's a collaboration in play. So rooms have now been transferred instead of these big boardrooms to smaller spaces that can be changed, reconfigured, or they're a standard 4 to 6 person room. We're seeing a lot more of that, especially with the video conferencing systems, the Zoom rooms, and with Teams making a push as well. These rooms are becoming what our integrators are installing on the commercial side day in and day out. So, you guys have typically seen the under the table hatch, or you have a mount with whether it's a back box behind it or a small cabinet where the gear goes, but everything has to be clean. Everything has to be put on a specific location. So those are the two major applications that this has come from. I will say that since we've been talking about it in the field, some of the other applications that have come up have been the digital signage world, because it does provide the 15 amp and 20 amp power for the digital signage space, as well as we've seen an application for residential for some of those smaller theaters or the or smaller rooms, as well as the ability to have that monitoring and metrics on the diagnostic side in a rack at all times. So there's a lot of different applications. You can get creative with where you want to put this.
Yeah, yeah. Actually, with the way that racks are constructed with the horizontal structural members, on the side of the rack, they provide the same hole pattern, so we can put it, on the side of the rack and put it in residential applications and racks and that kind of thing. So it was really cool. Yeah, we showed it at the ProSource show, and there was people very interested in the Resi world in this unit as well. So it's fairly small. If you guys are familiar with our SA82AR, the AR version, it's similar size to that. So as you can see from this picture here, behind displays, mount up underneath tables or in racks. Very good. Thank you, Lauren. I'm gonna now turn it over and get Dean into the conversation. Dean, you still out there with us?
Yes, I am.
Very good. Of course, Dean Phillip is the lead design engineer for the Squid product, the project, and the project lead. So Lauren mentioned 3 different SKUs. You want to go a little bit more into the difference between the 3 SKUs here?
Yeah, sure. So you can see on the left side, the only visible difference on the 3 units there are the colors of Phoenix connectors. So it's going to come in 3 SKUs where the only variation is the DC voltage output. So one SKU will be all 12 volt output, one SKU will be all 24 volt output, and the last will be half and half.
Half and half, yeah.
All of these units still come with the 5 volt output, the orange connector next to the main larger Phoenix connectors. And that's going to have 2 USB-A connectors and then the 1 Phoenix connector. The USB-A connectors can handle 1 amp each. And the Phoenix connector can handle up to 3 amps with a max power of 15 watts on that 5 volt bank.
Very good. So this is not a shy unit when it comes to a DC. I mean, it's going to put out some juice so that our users will be able to use it for a variety of devices.
Yeah, that's right. So the main DC banks are going to support 140 watts of power. Whether that's 12 or 24 volts, each DC bank is going to be 72 watts.
Very good, very good. And then
yeah, so it's a lot of power to play with.
Yeah, yeah. How are we handling the 120 and 240 volt application? I guess we'll see that when we go into the user interface. Is there going to be something that you need to tell it which version it is?
So you're not going to have to tell it which version it is if you order the specific SKU that's already set up for that. So if you order the SXDC-8-12-120, it's already going to be set up for a 120 volt unit. But you can go in after the fact if you realize you ordered that SKU and then you wanted to use it in a 230 volt application. You can just go in there and flip a toggle to make it an international unit essentially.
Excellent.
As far as the physical configuration, there's nothing that needs to be done. And whatever power is put into the device on the AC side is going to be put out of the device on the AC side. So those 4 individually controlled IEC outputs will either output 120 volts or 230 volts, depending on what you put into the unit.
Gotcha, gotcha. So it's hard to see in this picture here with the size that's on there, but right between the USB A connectors and the Ethernet port, there's a little USB on the go port. What is that guy for?
That is for local configuration when no network connection is available, or if you're troubleshooting an enterprise level connection on the Ethernet side with the 802.1x or LDAP, then you can use that for local configuration to be able to view what errors are coming up with your configuration. Maybe you're not super familiar with how to configure an 802.1x system and you have something put in wrong. So that'll give you a little bit more information to be able to debug that.
Excellent. Let's talk a little bit more about 802.11.1x. What are some of the benefits that our users will have? That since we support that.
Yeah, so that's primarily geared towards enterprise level accounts. So a lot of these enterprise customers require network security on both the hardware side and then on the software authorization side. So 802.1x is going to be your low-level hardware encryption, so it's going to encrypt all the network connection coming out of our device going to whatever device it's connected to, whether that's a network switch or a standalone computer. And the Active Directory is going to allow you to have all these users set up in your Active Directory database, be able to access the device and have different authorization levels. So a user that's only allowed to turn on and off devices, if that's going to be a remote service tech, will not be able to do firmware updates or network configuration changes, but whoever's going to be configuring the devices in the field will have those authorizations to do so.
Excellent, excellent. And what about use with a control system? Are we going to have some APIs available, for compatibility with control systems?
Yes, we are. So unlike our previous Access Elite and Envision lines, we're going to have a full REST API supported on the Squid device. So we suggest using this REST API for any control or monitoring. So that's going to be supported for both HTTP and HTTPS if security is required.
Excellent, excellent. All right, well, at this time, I'm going to change the presenter over to Dean because he has Squid up and running on his computer in Raleigh, North Carolina.
All right. Can you guys see?
All right, very good. So on the opening screen here, I see that on the right side we have the system status, very similar in to what we have in Access Elite. Different graphics, but your overall system and your surge protection checks. We have the line voltage coming in, so your incoming line voltage meter there. Now the current that we see there, is that the total current for the entire unit?
Yeah, that's right. So the monitoring that we're doing is going to be for the full unit, and that's going to take into account both the DC current and the AC current. So any DC connected devices, the current and power draw is going to be measured on the AC side before our AC to DC converter. So all of that is going to be aggregated together in that current and power measurement.
Excellent, excellent. All right. So in the center, we have our six outputs. The only one that's not here, of course, is the 5-volt output that is on all the time, but you have control over the 4 AC outlets up top and the 2 DC banks down on the second row there. I see that we can have an alias for these outlets. So maybe show us how you change the individual
Yeah,
outlet.
sure thing.
Yeah.
So it's really easy just from this main power management page to be able to change both the reboot time and the name of the device. So pops up a little popover allowing you to change the name or to change the reboot time if you have a shorter or longer reboot time. So you can see here that the monitor, we want to have 25 seconds to wait to allow it to fully turn off before we actually turn it back on. And the Apple TV and the cable TV box are going to be slower or faster reboot times because they respond quicker.
Very good.
Yeah, so we allow that flexibility right here on the page to quickly change those.
Excellent. So upper left corner of each one of these boxes, that's the on-off for. The toggle on-off. But so the difference between toggling and rebooting, I'm sure everyone out there knows, but just go over that real quick. That's the difference between the two.
Yeah, so we can just toggle off the cable TV box if we want to. But let's say we are rebooting the network switch, which we have down here. If I were to just toggle this outlet state, then we would lose connectivity to the Squid device itself. So instead of just switching this off and then switching it back on, we allow the reboot button to be used, and we suggest that the reboot button be used normally because the Squid device handles that internally. So it takes the one action and it knows that it needs to wait that specified amount of time before it turns that outlet back on itself.
Yeah, so one command does the turn off and then waits, then turns it back on. Yeah. So I think in doubt, always use reboot over turning something off.
Yep.
Keep you out of a jam. Very good. All right. So let's say you have a Squid device and you just are installing it. What are some of the things you need to do at the front end? Of course, you would set all your aliases up based on what you've got connected. But what is the next thing you want to do?
Sure thing. So I'm just going to run down this whole setup tab.
All
So
right.
the first thing I would do is go into the device, and this is your highest level configuration. And this is very similar to the access lead also. So you have your device name, power up delay time, and then you have a power up and a shutdown clear setting. So again, very similar to access lead. You can either use the initial state of the outlets, or you can run a sequence. Right now we have it set up to just run the startup sequence, but we could change that depending on our need. The initial state, if you're not familiar with it, we use that in the access lead as well. It's going to have a couple of options. So we can keep the outlet always on. Always off is probably going to be rarely used unless you want to ensure that no one else is plugging in other devices in that room. On, off, and last. So the last is going to, is going to turn the outlet onto whatever state it was when you lost power. So if outlet 2 was on, it will turn back on. If it was off, it will stay off when the unit powers back up.
Gotcha. And these are really kind of programming choices that the user will make at the time. Do you want to boot up with a known sequence, or do you want if the power should go off and come back on, you want them just to come up to the last state? My personal preference is I like to boot up using a known sequence, because that's the whole idea behind this thing, is you want it to boot up with a particular sequence. So, but in others of these seminars, sometimes we call them user groups, where we talk about the details about how to set these things up. All right, so let's keep on going.
Yeah, so next I would go into the network settings. Obviously, this is going to be similar to every other network connected device. We can change the IP address, subnet mask, gateway, DNS. We also have setups for SSL and HTTPS. And then we also have our date and time settings, so you can change the time zone in the NTP server. Or obviously, you can also set the time manually. This will also be where you set up the 802.1x and LDAP or Active Directory if you're going to use those for the enterprise level accounts. We're just going to gloss over that today because it's not required to use the device. It's only going to be really used if you're in that space where you do have those strict network security requirements. But this is where you would change those settings as well.
Excellent.
Next is the advanced network settings. So this is really mostly the SNMP configuration. If you have an SNMP manager that's going to be looking at your network devices that want to know when certain things are happening, whether there's a network error or for us also a power error, we can set up a device to be able to get those traps here. So to get those notifications that something has happened and that we have either taken action or not taken action.
Gotcha.
Going down this, again, setup path, we can go into the users. You can see here that there are 2 users set up right now. There's an administrator and a tester that's set up as a user account. So you can see these are not buttons, but rather indicators or notifiers that that person has that authorization to change a trigger configuration. The administrator obviously has all the different configuration options. They can configure triggers, they can control devices, change network settings, software update, all that good stuff. But here you can add really as many users as you need locally, or you can create an LDAP user just by entering a username, name, and email, no password needed.
Excellent, excellent.
Moving along, we'll go into the triggers. Not going to go too in depth here. This could probably just be a webinar in and of itself. But we do allow a lot of configuration in these triggers. So previously we had very limited configuration. You can set an overvoltage and an undervoltage turn off from 80 volts to 100 volts, something like that. Here we get a lot more in depth, and you can see that the configuration is a little daunting. If you order the 120 volt SKU or the 230 volt SKU, there will be triggers set up already by default. So that will be a little easier to kind of just plug and play and go with the device. But this will allow you the option to customize all of those for whatever specific need you have in the field. And then finally, the last piece of setup is the sequences. So on the last page, you can have a trigger when there is an undervoltage sequence off devices. So here you can create a sequence. You can name it power off sensitive. So you have sensitive devices that you want to power off, maybe the Apple TV and the cable TV box. You can remove any unwanted steps, change the actions to off. And there's a 5-second pause in between turning the Apple TV and the cable TV box off. You can get that sequence. So very simple, very similar to Access Elite. And then you would create the trigger on the previous page to actually run that sequence.
Excellent. Yeah, and that looks good.
So that's really all the setup and everything that is very similar to Access Elite.
Exactly. Yeah. So again, the beauty of the Squid is that it is an Access Elite and an Envision inside a hybrid AC/DC power center. So now let's talk about the Envision part of the Squid.
Sure. So for those of you that are familiar with the Envision and the bar on the right side of the software that tells you what events have happened, this is what this chart interface is for, the pie chart interface. So you can see here we've only had one undervoltage event and one network auto ping event. But if this chart were to be full of undervoltages, overvoltages, you're going to see variations, any of the parameters that we measure and can trigger on, then you would see what your main culprit is. You'd see what trigger is happening all the time. Or maybe you have one event pop up on here that you never thought would happen. Maybe that is what caused a problem in the field. So this is going to give you a quick and dirty look at what events have triggered and what's happening more frequently.
Gotcha. And what's interesting about this this new chart mode that you've got here, it's not only going to show you the events that have happened, in other words, the disturbance events that are happened, but it's also going to show the triggered events. Like if some event triggered an action, those will show up on this chart as well.
That's great. Yep.
Yeah. Excellent.
So now we'll move into the reporting tab, which is, again, very similar to Envision, but laid out very differently. So here you can see a little calendar on the left side, and there are little alerts that tell you that events have happened on that day. So right now we just have Thursday selected, but we could also select the 18th. And scroll through this list to see that outlet control had occurred. There were some undervoltages that occurred. The user failed to log in and was denied access, probably because they didn't have the correct password or just mistyped the password. A lot of different events are logged here, and you have the ability to export all those events as a CSV also.
Excellent. And the thing that I like about our new reporting scheme here, we're not only like the Envision, we're marking both the onset and the recovery. But what's great is on that second line, if it's a disturbance event, you see what the threshold is going on, and you're going to also see what action was taken during that event. So because some events there may be no action was taken, but you have all the information at your at your fingertip in each in each one of the entries.
Yep, that's right.
Excellent, excellent.
So that's the timestamped events. Now, again, similarly to the Envision moving onto the historical data, this is a very new demonstration of historical data, and we revamped it a lot. So before in the Envision, you have fixed 30-minute intervals that will log min-max average data. Here we're logging all of these different parameters. So we're able to pull up the line voltage peak and also when this finishes loading, RMS values, and we can graph those over time. So actually, we'll just leave it at this for now. But you can see that this is from March 13th to 19th. We had a very constant line voltage peak, and we can use the bar down here to zoom in to a specific day. So we'll just go most recently. And you see that there's this little gap here from, let's see, 3 o'clock, between 3:10. Oh. It looks like I lost my spot.
Yeah, well, I think we should.
There's the ability to actually look and see when a power outage happened. So.
Oh yeah, I see what there. Yeah.
And 4 o'clock there was a power outage.
Yeah.
So it allows you to kind of dig down and see more granularly what's happening on site, and you can change that the time slots to be from a day to every 2 seconds. So if you dig down and see what's happening min-max average for every 2 seconds, you're able to do that, and you can store a day or two's worth of data going that granularly.
Yeah, that bears repeating. So just for the Envision users out there, you're probably familiar with the 30-minute window that the Envision is set up that every 30 minutes at the end of a 30-minute window after the unit is plugged in, we are looking at every 3 cycles. We're looking at what is the maximum, the minimum, and then we're taking an average over that 30-minute window. And at the end of the 30 minutes, we record those 3 parameters just for the voltage level. We're recording other parameters as well, but it's at the end of the 30-minute window. With this device, with the Squid, you're able to set that window, that time window, to whatever you want. So if you want really fine data, and actually, where do you set that up, Dean? The reporting window under device?
Sure. Yeah, so that's going to be under setup device, and it's going to be this number down here, so data logging interval.
Yeah, so if you're recording every 10 seconds, you're going to have a really detailed picture of what the voltage or what all those parameters are, neutral to ground voltage, and we're going to go back over that parameter table and look at the number of parameters that are doing. But as Dean was showing here, you can set that window to whatever you want. If you want to go to the traditional 30-minute window, or you can go to an hour or to 1 day. The good thing about having the 1 day or the 1 hour window is that you can have data that goes back. I don't know if we've done the calculations yet, but probably 6 months or more. But if you go down to the 10-second range, what are we thinking, Dean? Maybe a week's worth of data at the 10-second range?
Yeah, so shipping the units, it's going to be default at 10 seconds, and it's going to be about a week's worth of data.
Okay. All right, so we just need to keep that in mind for our users out there, that and usually you're going to be able to get to this unit within a week of having an issue, because remember, the remote data acquisition or data access is built into every one of these units. So as long as you can get onto the network, you can grab this data, and if it's at the 10-second mark, most likely you'll be there within a week to be able to capture what happened in the past. But going back to that, to the list of parameters that you are now recording, it's really great. And the Envision, it's 5 or 6, but here is what about 20 different metrics that we are able to capture.
Yeah, I think it's actually closer to 30, but it's a lot of different metrics to be able to diagnose any kind of power issues that you're going to see at a site.
Excellent, excellent. I think this is, for me, Dean, I'm going to be honest with you. This is a build it and they will come kind of situation where some of these parameters we don't know what we're going to find, right? When we start collecting this data and seeing what we can discern from this data that we're collecting.
Yep, that's right.
All right, so this is how you logged into the unit. Very good. So,
and then one last thing before off of the demo, Vince. Under the administration on this bottom left side, you also have utilities to be able to save configuration files. So if you do have 20 or 100 units to put in one location, you do want them to have all of the same configuration. You can set one up, download the configuration file, and send it to all of the other devices. And we will have a management tool that will be able to discover all the devices on the network and send them all the configuration file at the same time.
Oh, excellent. Excellent.
And then there's also a file upload tool to do a firmware update or upload any security certificates that are needed for enterprise level customers again. And then a general system info to be able to get the MAC address and information that's needed for troubleshooting.
Very good. Well, Dean, I can tell you that I think you've done a wonderful job on this.
Thank you very much.
But I think it is an excellent extension of both the Access Elite and the Envision, and it's gone far beyond both of those units, and I'm looking forward to this being the kind of like the SurgeX default platform from now going forward. I think we're going to see very similar in future products, very similar user interface.
Yep, that's our goal.
Excellent, excellent. All right, if you want to throw the presenter back to me.
Sure thing.
And guys, while we're doing that, we did have a couple of questions that came in that I don't know if we want to try and address now, but
yeah, I think so. Let's do it.
So one of the questions, and there's actually two that are similar. They're both relating to managing multiple units. So one question is there a GUI when using multiple units on one site? And then how do you manage multiple devices at a site and then multiple sites?
So there isn't going to be one specific interface that shows all of your different units outlets per se, but the discovery tool will allow you to have a list of all the units on the site and to select them to dig down into a specific one, which specific one in which room you want to get to. And each one's going to have a specific name associated with it. So you can name it Squid Room 121 and click on that one to dig down into it. But there won't be one specific interface showing all the different outlets, if that kind of answers the question.
Yeah, and I think, Dean, this relates back to kind of what next steps and next level is for development within the IP-based applications for us, and that relates back to that cloud infrastructure where we can manage it through a tree system or whatever it might be. So that is something that we're looking at for next steps. But a lot of the feedback that we get too from our customers is that they want to manage it through their VMS and their FMS. So the way that Dean has built the protocols for this product, you will be able to take the data and the information from multiple units and tie it into your own, whether it's your restaurant system, your building management system, and be able to view it and drill down into it that way as well.
Yep, that's exactly right.
The other question that came up was, can multiple Squid units share the timestamp data or timestamp reporting calendar? So I think what this means is, if you've got 5 or 6 units on site, will their reporting calendar can you get all of the data from 3 or 4 different devices onto one calendar?
On the discovery tool, they won't show one specific site, but you can dig down into each one to look at its specific calendar. So no, there won't be one calendar that shows all the events. And it's meant for to use its REST API to grab everything, all the data you need, and display it however you would like.
And actually, another way, Dean, that I might use it is if I download it. I know there's an exporting feature, a download feature that you can download the data into a CSV. Is to put them in, individually download them into different, individual CSV files, and then merge those CSV files and see if you've got common disturbances. That's something I do quite a bit when I'm checking out customers' Envision logs. On some occasions, I'll have an installation where there's more than one Envision at an installation, and that's the way that I've done it. Just bring it into a CSV and start comparing on the Excel spreadsheet. See what's common, what it's not, which is a great way of seeing if your problem is a global problem or a branch circuit problem. Very good. Any other questions before we?
It looks like we've got everything there.
Very good.
Sorry. Can you set up? Sorry, one more. Can you set up auto time reboots on a daily or weekly schedule? And I can take this one. So yes, you can. You can set it up on. I think it's a daily, weekly, monthly, or yearly schedule.
And that's going to be set up in the triggering section also.
Correct. All right, so I think we're good, Vince.
That's it. And all right. Well, that about sums it up for this edition of the Power Hour. The Squid is a game changer. Having reliable AC and DC in the same remote accessible unit with extensive diagnostics will surely help you provide great service to your customers. Thank you again to Lauren and to Dean for your time today in bringing this unit out to show everyone. The Power Hour is brought to you the second to the last Thursday of every month here by SurgeX. Our next webinar will be April 23rd, so pencil us in and look for an invite for our next Power Hour. Remember that previous Power Hour webinars are available online. You can see the link below there at the Go to Stage channel. You can access these webinars, and again, there's other videos, other interesting information about power and about our product line. So with that, Lauren and Dean, thank you again, and we'll see you next month.
Thanks, everyone.
Thanks, Vince.